Hello. I realized I've built an entire second train and I haven't done a single video about it. So what I'm going to do is I'm going to deconstruct this train so you could kind of see how it went together, but in reverse. First, I want to show you the tools and my workspace. I've done all of this here just on this workbench. Some of the most important things I've used is this drill press. Ooh, sorry about that. I have a small cutoff wheel and a bench grinder right next to me. This vise is extremely handy. So, torch and solder. And I'll show this as I deconstruct it, but the train is 1 inch by, I think that's 1/8 inch machining brass stock. And then for the sides of the floor chassis, it's a K&S brass strip, 0.064 by 1/4 inch. So I cut them all to about an inch and 1/8 long, and then I had to solder them together. So I'd clamp them in my vise and solder them. Then I had to use various very small drill bits. And then I've got taps. These are number 256 taps. And that would allow me to thread all the holes that I drilled. These are for 2mm screws. These are drill bits and taps. Two sizes of screws. I used number 2 screws, and then I used 2mm screws. Another very important tool I used are these tweezers with these fine tips. Oh, also I used various types of screws. These are Phillips head countersunk or flat head. These are socket head screws, number 256. I also used number 256 flathead screws, but these are hex instead of Phillips. Now, to deal with screws this tiny, I used a precision screwdriver kit, and this has various Phillips, hex, and star drives, and flathead. A micrometer, you might also know it as calipers. This is really great when needing to transfer a measurement. Here it is. Let's say I've already built one chassis and I need to find the center. So I'll take the calipers or the micrometer, I'll measure the width, and it gives me 25.52 millimeters. So that's what, 12.75? Let's see. So I'm going to set this to 12.75. Wow, right on the dot. Oh, as I tighten the screw down, so it's a 12.76. So I'll take the flat brass and then I'll scratch an edge from one side and then scratch again from the other side. There we go. And those pair of scratches are right at the center of the brass. That's great for when I have to maybe drill in the center or line something up at the center. So let's see what else. Oh, Dremel for fine cutting. I use most often these cutting discs, but I also used these sanding stones when I had to shave just a little bit of brass. A countersinking bit. Man, this thing is useful. And then various pliers knife, a file. Yeah, so let's get to disassembling the train. Okay, I'm changing tact a little bit. I've got the front car disassembled. Here's the brass piece cut into the shape. This is that flat brass. And then these channels on the side are that brass strip. And what I did is I clamped it in the vise and heated it up from underneath and applied solder here and here. And then I moved on to drilling. So I drilled along the edge, just a little bit in from the back. You might be able to see the scratch mark. I measured out a certain distance and scratched each of the edges of the chassis so that all my chassis were drilled roughly the same spot. And then I tapped that for the number 2 56 screws. This one, being the front car, has to couple to a 0 car. This was a solid brass shaft that I drilled and tapped a hole as close to center as I could. I knew it would be off center, which actually helps in the situation. And soldered that in a bit of square tube. And this is what I was talking about, using my calipers. I could make scratch marks on either side to make sure this is lined up. And then I drilled and put a screw in to hold it in place so I could solder the whole thing. And then on the 0 car, kind of the same thing. You've got a bit of flat brass with that flat channel soldered on either side. Drill and tap out the holes for the wheels. And I soldered a bit of, this is just a brass tube that just snugly fits over that brass rod, but it allows for rotation. And the reason I needed this to be off-centered, because I used one of those socket head screws, and when I screw that in the front here, the edge catches the socket head, so that won't come out. I screw that all the way down. This tube is sanded just a tiny amount shorter than that post. It'll still rotate, but it doesn't shift forward and back except the tiniest amount. Here's the 3D printed nose for the 0 car. What I did with this is I cut a piece of brass and glued it to the bottom, and then I drilled through and I tapped and put some 2mm screws. So it's glued and held in place by those screws. Then I drilled through the chassis and they line up with those 2 screws, so I could put this on and take it off as needed. This is the lead car. I did not design this car, I merely printed it. These handrails or grab rails or whatever these are that go around the car, being 3D printed, they came out okay. They were acceptable, but they were really fragile. So I took a bit of servo control wire and hand bent it to match as close as I could, and then cut away the printed ones, melted a slot in these attachment points, pushed into the sides of the car, and then I glued it in place. And these came out really nice. And again, I took a bit of brass, cut it to fit into this cavity here, and drilled holes to line up through the chassis. And then in the seats I have 2 2mm screws that go through and into the same channels. So I have to take all these off and I'm going to paint them. I still haven't figured out what I'm going to paint them yet. But let me show you how I assemble this. That was a long intro. The bearings that I used for the
cars, I use two sizes. I've got road wheels and then I've got guide wheels. The road wheels are 5/16 of an inch diameter, 1/8 inch diameter interior, thickness 9/64. And the guide wheels, 1/4 inch diameter, also 1/8 inch interior. Their thickness 7/64 of an inch thick. For the road wheels, I took one of my black flathead screws. Then I take one of the road wheels, set that, and then one of the brass washers. Man, I've done this so many times. So now taking my hex miniature screw, or miniature screwdriver, and then I start threading onto the chassis. Now, that being countersunk, it's going to center the wheel as it tightens down. And I've got the road wheel in place. And spin it, make sure it's free. Then you would repeat for all the other wheels. So I need a longer screw for the upstop. I've cut a bit of aluminum channel into these teardrop shapes. Actually, I drilled the hole first and then I cut the aluminum around it, but then I countersunk a hole into one edge of it. When this is installed, that screw does not protrude above this plate, or it'll be below this plate. I need one brass washer, and that is so the bearing, the center ring of the bearing is lifted above the rest of the aluminum so the outer ring doesn't become a problem. And now I have a number 2 56 nut. Because the countersunk head doesn't touch this bearing is kind of free to shuffle around. So as you tighten this screw, I start by centering. So what I've done is I've centered the bearing, and now I'm just going to give it a little snug up with the screw and some pliers, because that upstop dog may need to change. Each of these assemblies, I know, take 3 of these brass washers. Same deal. You put it on the holes that were drilled and tapped for each of the upstops. Screw it down till it almost snugs. And I see where my upstop comes to rest, and I don't like it, so loosen that a little bit so you can turn the upstop. And now I know it's going to turn as I tighten the screw and get it right to line up right over the wheel. So now I do a visual inspection to make sure that the guide wheel hasn't slid too close or too far from the edge. I don't know if you could tell, but it's slid outward towards the outside of the car. Not enough for me to worry about it at the moment. I'll check alignment once I put it on the track. Each of these cars have had some play. So now I just repeat for all the corners. The other thing that goes on the front of all the cars after the first car, this is a ball link, threaded ball link. That plastic cup threads onto this brass connector. I shaved off half of this thick spot here. Then I super glued this in place temporarily, and I drilled and tapped it, but you can see I countersunk the screw, and it's completely flat if I had to do anything, because I didn't know what chassis was going to end up where, so I made them all like this. Once that was screwed in place, I was able to solder it, And as you can see, this shaft is pretty long by comparison. So using my Dremel, I cut off about half of the threads, threaded the cup. And what that does, that cup lines up to these steel balls with a threaded shaft on it. The way I attach those is I use a small piece of brass channel. It's a little square channel here. I cut it to length and drilled a hole in it, ran the stud through there, bolted it down, and now I put this whole thing back in the vise upside down and then heated it up, and using my tweezers held it in place until that nut lined up with the scratch marks to get that ball as centered as possible. And I also wanted the ball to be aligned with the wheels. Rinse and repeat several times. Oops. Some of the changes on the other cars, like this one has nothing. These two cars have magnets on them to catch the brake spring. This is a transplant off of Phil's original car, and then I'm using high power magnets that are already countersunk. These are more powerful than these, but what Phil has done with this contraption is allowed for an adjustable height on that magnet. By loosening a bolt, it unclamps a magnet, and you can raise and lower it and clamp it back. Plus I wanted a little bit of extra weight on the train. This last piece here is a conductive arm. The spring that the magnets grab is on a motor, and that touches a brass plate to turn on that motor. So when it comes into the brakes, this piece is what turns on the motor by completing a circuit through the track. I guess the last thing to talk about is this chain dog. This is the same square channel that I used to mount the ball joints. I took a bit of servo control wire, there, bent that into a hook, and soldered it into the tube itself, and then made these channels by cutting a large square piece of tubing in half and lining it up and mounting it. So that's how the train goes together. Oh, one last very important tool. This is phenomenal for working on miniatures. So get yourself a magnified visor. Last thing I'm going to do with this is I'm going to paint the train. Oh, I have these. These are lap bars. And if I get this right, these will actually be able to pivot. That's my hope. And after that is going to be adding sensors. Oops, it's over there. Sensors to the model. Adding sensors and writing some code maybe to run it. I know zero about Arduino. It's going to be 2 trains and a transfer track. I think I got the 2 trains sort of sorted out. I've been watching videos on model train block signaling and management, so I think I understand how to do that. But once you introduce the transfer track, I have no idea. I'm really good with my hands, not so good with the computer. Anyway, thanks for watching.